Hello, ladies and gentlemen, and thank you for joining me for question number 14. The two equal arm scales shown are balanced. So what do we got? Three circles weighs the same as two triangles. A square circle and a triangle weighs the same as two squares. That's what they're trying to show with these balanced scales. Of the following, a circle and three triangles has the same mass as... Okay, so if we had another balance, which would balance with a circle and three triangles? Would it be three squares? Is the A the answer? Okay, so how can we work something like this out? Well, there's a couple ways, and I actually went through this question on the grade 7 paper. So I'll briefly mention one way, and this is way it only sort of works if you can really see it. And sometimes the question isn't even set up to be done this way. But notice in this second one, I've got a square on both sides. We don't really need that. So what we're really saying, if we take off a square from both sides, a circle and a triangle will balance with a square. Okay? A circle and a triangle. Oops. So that's what we learned from the bottom scale. Okay? So this can be replaced with a square. Now on the top scale, we see, oh, I've got two triangles, and I need to know about two triangles. Two triangles is the same as three circles. So you can sort of play around with what you're given and just sort of by inspection see that this is going to weigh the same as three circles and a square. Okay? But that's kind of lucky. It's lucky that they presented the right amount of information for us to sort of piece together the one we're asked for, and we're lucky that what we were able to piece together happens to be one of the answers. Okay? A more complicated version of this question wouldn't lend itself to this sort of inspection solution method. Okay? So what could we actually do that's going to work every single time that we can reliably understand? Well, these balances are really just equations in disguise. Okay? What we've got here is three circles is two triangles. So it's an equality with sort of some algebra. Or you could say 3C circles in triangle. Right? If you want to do it that way, I'm going to keep it with the shapes. Okay? And then the bottom one, a square, a circle, and a triangle. So if you have all of them, is two squares. Okay? Now, what can we do from here? Well, we've got two equations and three unknowns. What we could do is we could solve for each of these in terms of one of the variables. So I think when I did the grade 7 Gauss paper and we did that question, I solved for everything in terms of triangles. I'm going to solve for everything in terms of circles here, just for fun. Okay? So if I want to isolate for triangles in this equation, divide both sides by 2. A triangle is 3/2 of a circle. Okay? Now, just as before, we can take away a square from both sides and say, a circle and a triangle is a square. Let's solve for squares in terms of circles. Well, we can plug my triangle knowledge in here. Okay? And say, all right, one circle plus 3/2 of a circle, 5/2 of a circle, in total is one square. Now I know what squares are in terms of circles, and I know what triangles are in terms of circles. So what we can do is we can go to each one of these expressions in turn and express them purely in terms of circles. And this is not a bad approach because, look, we've got lots of circles present here. So C is just 4 circles. Now what about the one that we're being given? It's one circle and 3 triangles. That's going to be one circle, and then 3/3 of a circle, so that's one circle, 9/2 of a circle. So we're looking for something that means the same as 11/2 of a circle. That's what we want. Okay? So we can just line them up, A, B, C, D, and E. Now E was 3 circles. Well, that's not 11/2 of a circle. C is 4 circles. Now D was 3 circles plus a square, right? But I know a square is 5 halves of a circle, and 3 is just 6 halves. So we get 11 halves of a circle there. So that's how you can tell D is the answer. But we haven't finished evaluating the other one. So 3 squares on top. That's 3 5 halves of a circle. So that's going to be 15 halves of a circle. So that's not the right answer. 4, no, that's not. And then I think it was 2 triangles plus 2 squares. Yes, that's what B was. And so that would be 2 times 3 halves of a circle plus 2 times 5 halves of a circle. So that'd be 3 circles plus 5 circles. That'll be 8 circles. And that also absolutely not the right answer. Okay? So we just plug them in and evaluate them all. We just reduce everything to the same variable, but the shapes, not letters or numbers or anything anymore. Okay? But there we get D for our answer. And we're done with question 14, so on we move to question number 15. Until then, take care and have a wonderful day.